Instantiating a module. You have learned how to write a module in previous sessions. By writing a module, you are just creating a template of it, and in order to get the effect of that in your simulation and synthesis, you need to create an instance of that module. Every module in your program should be instantiated in some other module, except the top-level module. Typically, your design will contain multiple sub-modules in it with many levels of hierarchy. You should instantiate all modules in the design except the top-level module, which creates its own instance in the synthesis. In simulation, you will instantiate the design in the test bench module, and the test bench module will be the top-level module, which need not to be instantiated anywhere. This is the syntax to instantiate a module. Module name, instance name and port list. It is possible to instantiate the same module multiple times in the program, but each instance should have different instance name. For example, you will write a module to generate a FIFO, and create multiple instances of the FIFO wherever you need to use a FIFO. Module instantiation have different variation in Verilog and Systemverilog, which are shown here. Here a module is defined with name adder, which is having ports as sum, D1 and D2, all of them are of width 7 down to 0. It is instantiated in another module named ALU in different styles. Before creating instance of adder, many internal signals are named with names temp1 2 3 etc., sum1 2 3 4, sum, D1 and D2, which all are of width 7 down to 0. In the first instance, the module adder is instantiated with name add1 and its ports are referred by position. That is, sum1 will be connected to sum, temp1 to D1, and temp2 to D2. Next one, add2 is another instance of adder which is similar to add1 where ports are referred by the positions. Next is another type of instantiation. Here the module adder is instantiated with name add3, and its ports are referred to the declaration by name and not by order. Here D1 is connected to temp5, D2 to temp6 and sum to sum3. The syntax is, in the port list, a dot, name of the original module port, within brackets, the local variable. That is .d1, within brackets, temp5. Here the order of writing ports doesn't matter. This is called explicit port connections, where to specify which port to be connected with which variable explicitly. If your port's name are same as that of the internal signal names, you can use a simple declaration by using .*, which is shown here. Here the port sum in the original module is connected to the local variable sum, D1 to D1, and D2 to D2. This is called implicit port connection. You can also mix implicit and explicit connections, that is, few signals can be connected explicitly, and the rest, implicitly, using .*. It is shown here. The port sum is connected to sum5 explicitly, and rest of the port will be connected implicitly.